Today we'll be going over an overview of formulation development as part of the Fundamental of Biotherapeutics Development, Biotech 101. Today we'll be covering a variety of topics related to protein formulation. We'll start with protein degradation and the relevance of formulation. We'll go over some key considerations to take into account when formulating protein, and we'll dive into some pre-formulation studies that are part of our formulation development, and we'll go over some of the key protein formulation components, some of the excipients that the protein formulator has in his toolbox, and we'll wrap up with some of the late-stage development related to protein formulation. It's very well known that proteins degrade. The goal of the protein formulation is to minimize this degradation to acceptable levels. This is really important for safety and efficacy, and we want to minimize this degradation during processing and storage. Unfortunately, there's very limited information on the mechanism of degradation, and we do not have very many predictive tools. These protein degradation reactions are quite complex, and very often we start with a complex system with multiple variants and impurity. And you'll see in the upcoming slide that these protein degradation can be both chemical and physical, and they're very often coupled, which make things even more complicated. On this slide, you can see that we have multiple chemical degradation possible for protein. I've listed some of the key ones here. Deamidation is definitely something we have to worry about. It often occurs at asparagine residues, and it's favored by alkaline pH. Oxidation is another chemical degradation that occurs on specific amino acids such as cysteine, methionine, but it also occurs on histidine and tryptophan. And this is caused by dissolved oxygen and high temperature. We also have to worry about cleavage, and in this case, we're not discussing about enzymatic cleavage, but acidic cleavage favored by acidic pH. And sequences such as aspartic acid and proline are susceptible to this type of cleavage. There are also numerous other chemical degradation that can occur, such as cyclic amide, pyroglutamate formation, and bay elimination.